In this video, we're going to take a look at calculating the area of a regular polygon. We're going to start by looking at what you need to know before starting this topic. So first off, you need to know how to find the area of a triangle. You need to understand the sum of the interior angles of a polygon. And you need to be able to use SOHCAHTOA to find a missing side. So quick review, area of a triangle is 1/2 times the base times the height. If you want the sum of the interior angles of a polygon, it's equal to 180 times n minus 2, and n is the number of sides. And as far as SOHCAHTOA, if you're not sure how to use this to find a missing side, you need to go ahead and watch my trig videos. All right, let's do an overview of the strategy we're going to use to find the area of a regular polygon. First off, what does it mean to be a regular polygon? It means all 5 sides are equal, and also all 5 angles are equal. So, to come up with the area, we'll go ahead and draw a line from the center to one of the corners, or vertices, and if we add another one, we got a triangle there. If we add all the rest of them, you can see that this pentagon, it can be made up of 5 separate triangles. And it turns out every triangle is the same size. So we just need to find the area of a triangle and then multiply it by 5. To find the area of the triangle, we need its base and its height. All right, now we'll get into a problem and go through our steps to do this. So we're going to calculate the area of a regular nonagon, which is the fancy name for a 9-sided polygon, and its side length is 12 centimeters. So first step, we have to calculate what one interior angle is. So one angle is equal to 180 times n minus 2 divided by n. The top of that fraction is the sum of all the angles. And in a regular polygon, since all the angles are the same, we can just divide by the number of sides. All right, let's take a look at a picture here. I have not drawn an entire 9-sided shape. The more sides there are, the more difficult it is to draw them. We just need to focus in on what does one triangle look like. Step 1 will give us that angle that's highlighted there. So how do we do that? We go 180 times n minus 2 divided by n, and we're going to put in 9 for n. And that gives us 140 degrees. Step 2 is to go ahead and divide by 2 to get the angle of the triangle. So that light blue angle over there, that would be half of the 140, so that's going to be 70 degrees. We need to figure out the height of that triangle. But first, let's go ahead and label our side length of 12 centimeters. And now we need to figure out the area of that triangle. We have the base is 12, we have to get the height. But to get the height, we need to focus just on the right triangle part of this triangle. And so let's label our height h. Here's an important step. This bottom leg is going to be half of that 12. So it's going to be 6. And then we know that's a 70-degree angle. So now we're ready for step 3, which is to use tangent to calculate the height of our triangle. So if we go through and mark our sides, we got our hypotenuse. Opposite the 70-degree angle is h, and 6 is the adjacent side. We're not using the hypotenuse, so this is TOA. That's why our steps say to use tangent. So we have tangent of 70 degrees equals h divided by 6. Multiply both sides by 6, so the height is 6 times the tangent of 70 degrees. And if you put this on the calculator, you get 16.485. Step 4 is to find the area of our triangle, which is 1/2 times the side length times the height. Now remember, we're not finding the area of the right triangle. We're finding the area of the triangle on top. The side length that we need to use here is the 12. And the height is going to be our 16.485. So the area of the triangle is 1/2 times 12 times 16.485. Put this on the calculator, you get 98.909. Actually, if you put this on the calculator, you don't get that. You get 98.91. But at the end of this problem, we'll talk about the difference between those two answers. Now, step 5 is just to multiply by the number of triangles, which is the same as the number of sides, and this will give us our total area. So the area of our 9gon, by the way, if you don't remember the fancy words for certain side shapes, you can just use the number and put gon on the end. So a nonagon can also be a 9gon. So our final step is to multiply 9 by our area of the triangle, 98.909. And my final answer is 890.183 square centimeters. Now, if you do it on your calculator, you will probably get 890.19. The difference there is I didn't round the answers as I got them. I kept each answer on the calculator and just went from step to step, and that's how you get a more exact answer. Next problem. Let's go ahead and calculate the area of a regular hexagon with sides of 16 feet. So our first step is to find that purple angle up there using 180 times 6 minus 2 divided by 6. So we get 720 divided by 6, and that angle would be 120 degrees. All right, step 2 is divide that by 2 and get 60 degrees, which is the angle for our triangle. Now we got to find the height. And we want to actually focus on a right triangle here. And here's the key step. That 16 has to become an 8 to find our height. And now we can mark it. Hypotenuse, opposite, adjacent. And not using the hypotenuse, we're using tangent of 60 degrees equals h over 8. Multiply by 8. And you get 8 times the tangent of 60 degrees. Our height is 13.856. Let's indicate with an arrow the side length we just found, our height of the triangle. And now we're ready to find the area of the triangle. Which triangle? Not the right triangle, but that triangle highlighted in light blue. What's the base of that triangle? 16. And the height of that triangle is the 13.856. So we can use our formula, 1/2 times 16 times 13.856, and we get 110.851. Again, that's the rounded answer, but I have the complete answer still in my calculator. So to find the area of the hexagon, we'll go ahead and multiply 6 times 110.851, and our area is 665.108 square feet. Now, with a hexagon, there's actually another way we can do this. So I'm going to erase all the work and I'll keep our answer down at the bottom, but there's a quicker way to find the area of a regular hexagon. Regular hexagons are actually a special case. So let's focus in on one of these triangles and see what we can find out. We know that angle would be a 60-degree angle, and the one on top and the one on the left would also be. So this is actually an equilateral triangle here. All the sides would be equal to 16. And then if we divide that out into a right triangle, that 60 at the top gets split into 30 degrees on both sides. So we actually have a 30, 60, 90 triangle, which means we can use our pattern here. And if the hypotenuse is 16, the short leg would be 8, and the long leg would be 8 radical 3. So I'll go ahead and transfer those over to our small right triangle on the bottom left and erase to make some more room. So now we know our height is 8 radical 3. So our area of our triangle is 1/2 times 8 times 8 radical 3. Oh man, hold on. Stop everything. There's a common mistake that happens when we do these problems. I've been teaching this for almost 20 years, and sure enough, I still make the mistake. Can you spot it? Look, all I need to know is the base of the triangle I need the area of. It could be any of those 3 triangles or any of those 6 triangles. But I didn't use that one. I used the right triangle to get my 8. And that's not going to work. Look, it's not the end of the world. But you can't use the short leg of the right triangle for your base you got to use the 16. So let's fix that and get back on track here. All right, now we're ready. So 1/2 times 16 times 8 radical 3. You multiply all the numbers part, the 1/2 times 16 times 8, and you get 64 radical 3 for the area of your triangle. The area of the hexagon would be 6 of those triangles. When you go 6 times 64, you get 384 radical 3 square feet. This is the exact answer for the area of this hexagon. If you put that in your calculator, you will get the decimal answer that we got by using SOHCAHTOA. All right, first practice problem. Go ahead and pause the video and go through your 5 steps to get your answer. All right, so you could draw a little picture of your triangle. We've got 180 times 8 minus 2 divided by 8. So that would give us 135 degrees for our interior angle, which we divide by 2 and get 67.5. We're going to use our right triangle to get our height. We got tangent is 67.5 degrees equals h over 10, and work that out, you get 24.142. That gives us an area of the triangle as 1/2 times 20 times 24.142. Again, I have the entire decimal in my calculator, so I end up with 241.421. And the octagon has 8 sides, so it has 8 triangles. So we multiply that by 8, and our final answer is 1,931.371 square meters. Okay, next practice problem. This is actually a challenge compared to the ones we've done so far. So this time we're not giving you the sides, and there's a circle involved. So go ahead and pause the video and see how far you can get. You're going to have a different type of step 3 for this problem. All right, so what's our strategy here? We need to find the area of the circle and subtract the area of the regular hexagon. So let's start with the hexagon. We're going to go 180 times 6 minus 2 divided by 6. We get our 120 degrees for our interior angle, and when we divide it in half, we get 60 degrees for that triangle that we're trying to find. And then we can deal with the right triangle. We got 60 degrees, which means it's a 30, 60, 90 triangle. And notice the 12 this time is like this height of the hexagon. So if the whole thing's 12, that long leg is 6. And now if we put in our pattern for 30, 60, 90, 6 is equal to n radical 3. So let's go ahead and solve this and find out what n is. Divide by radical 3 and simplify it out. We get 2 radical 3 for the short leg. That means our hypotenuse would be double that. It would be 4 radical 3. So now I'm going to go ahead and mark this triangle up with what we got and erase to get some more space to work. So we just need the 4 radical 3 for the base instead of the 2 radical 3. So we have our base of our triangle and the height of 6. So the area of the triangle is 1/2 times 4 radical 3 times 6, or 12 radical 3. The area of the hexagon would be 6 of these triangles, which gives us 72 radical 3. Now we got to deal with the circle, and that means we have to know our radius, and the radius is the 4 radical 3. You can see how that goes from the center of the circle to the outside. So we're going to use pi times 4 radical 3 squared, because it's pi r squared for the area of a circle, and we get 48 pi. So now we can put these down at the bottom. We have the area of the circle, 48 pi, minus the area of the hexagon, 72 radical 3 square inches. That is actually your exact answer. If you put it all in the calculator, you can get a decimal answer of 26.089 square inches.